All right, so yesterday we looked at our second major category of energy, which is potential energy. So it's the energy that's stored up or energy of position. So basically it's dealing with the height that something is above the reference point and then the mass of that object, right? And so the equation is mass times gravity times height, or m, g, and h, right? We know that gravity on Earth is 10 meters per second squared. So even if the problem doesn't come right out and say it, you're assuming, right? So unless it's saying you're on a different planet or you're in some kind of simulation, it would have to give you what the gravity is so that you can finish out the problem. If it doesn't tell you what it is, it's just 10, right? Which is a nice, easy number to deal with calculations. So our units for GPE is an energy, so it's a joule. Mass is kilograms, gravity is meter per second squared, and height is going to be in meters. And it has to be those units specifically. So you can always kind of look back at this and kind of cheat to find the units that you need. Or use the units to help you decode what the variable is. So if it doesn't come right out and say that the height is 10, or let's say 15 meters, if it says it's on a branch that's 15 meters above the ground, and you don't recognize that that's height, you can look at the meters and realize, oh, okay, well I see meters, so that has to be meaning that the 15 is a height. So you can use the units to help you decode the variables, kind of work backwards. So just like we always do, we're going to circle what we are solving for, underline what we know. We can be solving for GPE, for mass, for gravity, for height. So there's really 4 things that we could potentially be solving for. You're always going to be given at least 3 of those things. Notice the triangle. Right, look, eyes up here. Don't be working ahead. Look here. GPE, and then this is our division line. So if I'm solving for mass, I cover up mass, and it'll be GPE divided by gravity times height. You have to do that multiplication, right? Then do your division. Right? If I'm solving for height, I cover it up, and it'll be GPE divided by mass times gravity. Again, do that multiplication, and then do your division. Right, and we'll see that in these practice problems. So, oh shoot, change the settings. Get to my tools. Hold on, thought. Go ahead and take a look at that first problem. See if you can identify the variables and get them filled in, in that first column there, in that first block on the left. Actually quicker than I expected. Okay, so it says a 3-kilogram blue jay is squawking in an oak tree in Mrs. Field's backyard. If the bird is on a branch located 20 meters from the ground, how much potential energy does it have? So we're going to circle. We're going to circle what we're solving for. So what are we looking for in this problem? What's it want us to find? What do you think, Charlie?
GPE.
Good. We are looking for the GPE, and so that is my unknown. So GPE or potential energy. Sometimes this unit you might just see capital P, capital E for PE. Understand that really we're only talking about gravitational potential in this unit. So either PE or GPE is all kind of meaning the same thing for us. All right, give me a piece of information, Dylan, that's given in this problem.
Well, we got the meters, and we got the height and the gravity. The gravity's already given to us what, but our height is 20.
Okay, let's go with that. That is great. We have height of 20. So I'm going to underline that, 20 meters. Let's see, Rory, what else is given?
The blue jay weighs 3 kilograms.
Okay, so that's going to be the mass. And then what is gravity? Good. So again, it didn't come right out and say it, but we're assuming that Mrs. Field's backyard is here on Earth. It didn't say it was on Mars or anywhere else, so we're assuming on Earth. So it says use the triangle. Well, here we're actually solving for GPE, so we really don't have to rearrange anything. So it's just going to be mass times gravity times height. So now I'm gonna plug that in. So I'm gonna take my GPE equals my mass of 20 times my gravity of 10, my mass of 3, which the order doesn't really matter, but I don't wanna confuse you. Mass is actually 3. 3 mass times gravity, and then my height is 20. And so really it's just plugging all 3 of those in, and what do you get?
600.
Okay, we have 600, and what are gonna be the units that I need to use? This is a type of energy, John. Very nice, J for joules. Okay, here's another kind of concept type question. Imagine now that it's a 6 kilogram blue jay, and it was sitting on the same branch, so it's at the same height. What would his GPE actually be? Same as the first, 2 times the first, 4 times, or half? What do you think? Without even doing, like, you could plug this in and do 6 times 10 times 20, right? Change this to a 6. Without having to do that, just looking at those 2 masses, what do you think?
1,200.
Okay, so that's not the answer though.
B.
Okay, why do you know that it's 2 times as much? Without having to do the actual math, how do you know that?
Because it's double the mass.
Okay, so you go from a mass of 3 to a mass of 6. Everything else stayed the same. So if you double the mass, you're gonna double the GPE. So if I would do that real quick, my mass was 6, my gravity is still 10, and my height is still 20. Just like Kate said, that would be 1,200 joules. And 1,200 is twice as much as 600. But you don't even have to do that. Just looking at 3 compared to 6, it's twice as much. So just trying to give you another way to look at it. What would happen if the object was if the ground is the reference point, if it was just above the ground, so it's like the instant before it touches the ground? How much height does it really have? What do you think? What if it's actually on the ground? So what if that bird leaves the branch and goes and lands on the ground? How much height above the reference point does that bird have? 0. So what would its potential energy be? 0. Because if you would plug in 0 for the height, anything times 0 is 0. So if it's right above the reference point or on the reference point, if it's basically 0 height, then you're going to have 0 potential energy. All right, so kind of keep that thought in mind too. All right, let's look at number 2. So it says a squirrel in a nearby tree drops an acorn and just misses Mrs. Sargent's dog, Caesar. If the acorn had 255.5 joules of potential energy and a mass of 1 kilogram, how high up is the branch from which the acorn fell? So what are we solving for in this one, Anthony?
How high up it is?
Okay, so height is my unknown. That becomes my question mark. Breeze, give me something that's given.
1 kilogram and 255.5 joules.
Okay, so my mass is my 1 kilogram. And what's the 255.5 joules? Which one does that represent? Let's see, Cheyenne? What's the 255.5 joules? Is that gravity or is that my GPE? Good. 255.5. All right, so what is my gravity going to be? Because it's not given to me. Okay. Good. Okay, so now I do need to use my triangle, right? Because I'm solving for height. So I'm going to set this equal to height. I'm going to kind of cheat and draw my triangle so I don't have to scroll. So I go GPE divided by mass times gravity times height. So I am now solving for height. So I'm going to cover up my height, right? What's the equation going to be that I'm using? Ethan?
H equals GPE divided by N times G.
Beautiful. Alright, so I'm gonna put that, GPE divided by mass times gravity. And then the process is still the same, we just plug in what we know. My GPE is 255.5, and my mass is 1, and gravity is 10. So I'm gonna just simplify that. I'm gonna make sure I do my multiplication first. 10 times 1 is 10. Now I'm ready to divide. And so what does my height become? Abigail, do you have that? 25.55, and what would the units need to be for this? Austin, what do you think?
Meters.
Good. Don't forget to do your multiplication first, then do your division. Good? Okay. Let's go to number 3. I think maybe if I remember right, this problem is not realistic with the numbers, but unless I changed it. I don't know if I did or not. But a gymnast exercises by jumping on a trampoline. At her highest point, she is 4.3 meters off the ground, and she has a potential energy of 11,466 joules. What is the mass of the gymnast? So, what am I gonna be solving for here, Audrey?
The mass.
So that becomes my question mark. Can I fill in gravity right off the get-go? I like to do that personally, that way at the end I'm not like, oh my gosh, I'm missing something. We know it's gonna be 10, unless, again, it says that it's not. Okay, so Selena, give me a piece of information that's given. Yep, 4.3 meters, that sounds good. So we're gonna fill that in for our height. And then what's the other piece of information, Emily?
11,466.
Good. Okay, so I'm solving for mass. So now I'm gonna rearrange my triangle. I have GPE divided by mass times gravity times height. And so now I'm solving for mass. I'm gonna cover it up. And so, Maddie, what is the equation I'm gonna use?
GPE divided by G times H.
Good. GPE over H times G. Is everybody good with where this is coming from, where that equation comes from? Okay. Mass, and my GPE is 11,466 over my height, which is 4.3, times my gravity, which is 10. Again, do the multiplication first.
Put parentheses if it helps.
Sure, if that helps, go for it. So you follow that. And so 4.3 times 10, 43, right? We can do that kind of mental math if you feel comfortable with that. I cannot do that mental math, that division, though. What's that answer? So once you do the multiplication, you do your division.
266.7.
266.7, yeah. I did not change this one. That is unrealistic. What will the units be? Good, because for every, to find what that would be in pounds, you multiply that by 2.2. So that would be I mean, I guess you could possibly have a 500-pound gymnast, but that's pretty big, and that'd have to be a pretty stout trampoline. So, yeah, not totally realistic in the numbers there. Yes.
Or they could just be like really buff.
Could be,
Insane.
but it'd have to be a very, very strong trampoline to withhold that mass. Okay, I would like you to do number 4 and 5. Look at number 4. It has part A, B, and C. part C, imagine that the balloon, is at the reference point. Okay, so at part C, it says how much potential energy will the balloon have right before it hits the boy sister. Imagine that the boy sister is the reference point, like hitting her is kind of like ground zero. Okay, and then when you get those done, I want to see them.
Yes.